Hello friends, welcome to the video, and in this video we will discuss the question which were asked in the DRDO interview with the detailed explanation. So this is the complete list of the questions which were asked in the DRDO interview, and we will discuss all these questions one by one. So here is the question 1. Who was the father of wireless communication? Sir J.C. Bose was the true father of wireless communication, who actually demonstrated the concept of wireless communication practically in 1895, but due to some historical reason the credit went to the Marconi. There is a complete story about it. I have put a link in the description, so please go through that link and know more about this complete historical incident as well. So the next question, how to tell about an antenna to a common man, right? So here's the answer. Antenna is nothing but a transducer which converts the electrical energy into electromagnetic energy. When antenna is used in the transmission systems, it converts the electrical energy into electromagnetic energy, or when it is used in the some receivers, it catches up the electromagnetic energy and converts that into the electrical energy. Or in another word, we can say that the antenna is nothing but an interface. This is a kind of interface between the wireless communication and the wired communication, because here it is the complete wired communication. And the next question was, what is the gain of an antenna and what is its directivity? See, the antenna is a passive device. Normally when you talk about the gain, it is defined for active devices like the amplifiers, the BJTs, MOSFET. So how do you define the gain for a passive device? See, the gain of an antenna is not like the gain that we define for MOSFETs or the amplifiers. The gain of an antenna is defined as a directive gain, which means how much power the antenna radiates in a particular direction as compared to had it been an isotropic antenna radiating the same amount of power. The isotropic antenna is nothing but an antenna which radiates the power same in all directions. Let's see this concept in more detail here. So this is the mathematical expression of a directive gain. Directive gain is a function of theta and phi. They are the spherical coordinates, and this is defined by the radiation intensity of an antenna. Radiation intensity is nothing but how much power it radiates in a solid angle, because it radiates the power in 4 pi solid angle. So in a unit solid angle, what is the power that antenna radiates, right? And what if had it been an isotropic antenna, how much power it would radiate? So how to calculate the power if it had been an isotropic antenna? You calculate the total power, this is P radiated, and divide that total power by 4 pi. This is the mathematical explanation, and this is the kind of chart, or this is the radiation pattern for an Hertzian dipole antenna. This is the radiation pattern, you can see that. So the gain, I mean how much power this radiates in a particular direction, the function of theta and pi, right? And this is the P radiated divided by 4 pi. I mean, if it would have been an isotropic antenna, this would have been its radiation pattern, right? So the maximum value of this directive gain is known as the directivity. Here you can see that in this direction it transmits the maximum power, right? So value of this power here divided by what is the power if it had been an isotropic antenna. So ratio of these two power is called this directivity, right? Next question, the question number 4, what is the virtual short and virtual ground concept in op-amp, right? Op-amp, we all know that the op-amp equation is given by V output is equal to A times A is the open loop gain in op-amp multiplied by Vp minus Vm. Vp is the voltage at its positive terminals, which is known as the non-inverting terminal as well, and this is Vn voltage at its inverting terminal, right? We all know that the gain of the op-amp is very high, right? So Vp minus Vn will be equal to close to 0, right? Let's take an example and see what exactly happens. Let's say the output voltage is plus 5 volt, right? And gain of the op-amp is 10 to the power 6. So in this case, if 5 divided 10 to the power 6, that comes out to be 5 microvolt. So the real concept of the virtual short is that because of the gain of the op-amp is very high, so the difference between these two terminals is not actually 0 but is close to 0, right? It's a microvolt. And in reality what happens is that the voltage as this negative terminal keeps on tracking the voltage at the positive terminals, right? And this difference keeps on adjusting itself to make the output finite, right? It was also asked that what is the actual difference between them. Nobody can tell the actual difference. It really depends what is the value of the output, what is the gain, right? So here I have explained the concept while making the op-amp as a negative feedback, right? So in this case I have applied a Vin at the positive terminal here, right? So this terminal will be close to the Vin, right? Though they are not connected physically, but since the voltage is more or less same, so it appears like virtually they are connected. That's why this concept is called the virtual short. And virtual ground is a special case of virtual short. If I make this positive terminal of an op-amp grounded, right, this voltage follows this ground, I mean 0 volts. So in that case this terminal is called as virtually grounded, right? Here's the fifth question. How does a solar cell operate, right? So solar cell is nothing but a p-n junction device, right? But the way it operates, it is completely different from a p-n junction diode operates, right? There are two things that we have to keep in mind while making solar cell. The first thing is that this is a p-n junction, right? This is the p-type semiconductor, this is the n-type semiconductor, and this is the depletion region between which formed because of the diffusion initially, right? But the interesting thing is that the n region, which is the top layer of the p-n junction solar cell, is so small. I mean, it is less than 1 micrometer, and the whole thickness of this solar cell is around 200 to 500 micrometers, right? This thickness is kept as low as possible, so that if any photon which comes from the sunlight strikes at the surface, the electron hole pair which gets generated should be generating as close as possible to the depletion region, so that the electric field which is present in this depletion region could separate out those electron hole pairs. Let's take an example. For example, let's say this is the photon which strikes here. The electron that gets generated starts piling up the top, and the holes starts piling up the bottom, right? And because of this pilation of holes and electrons holes, right, there is a forward bias voltage across this p-n junction. And if I connect a resistor, so the current starts flowing like this, right? So this becomes a power generating device in this case. And second thing is that the diffusion length of these holes and electrons should be more than this length of the device, right? I will make one exclusive video on how the solar cell operates, because it is not possible to explain this completely in a short video. So I'll make an exclusive video on this very shortly. So next question was, what is the relation between the Napier and the decibel, and the difference as well, right? So the short answer that we have to tell in one line was this is the relation between Napier and the dB. 1 Napier is equal to 8.686 dB. Right? Let's see this very quickly. Though this was not asked, I am just telling you for the sake of the information. Let's say I am having the ratio of two voltages V2 by V1. If I express this in dB, we all know that this is expressed by 20 log 10 base V2 by V1 in dB. If I express this in Napier, this 20 is no more here in Napier, as well as the log changes to log base E, right? Because the quantity is same, the V2 by V1, whether I express in dB or Napier, so I can equate these two. So if I equate these two quantities, this 1 Napier comes out like this, right? So the log base E V2 by V1 could be easily converted to log base 10 from here, because there is a basic mathematical formula. If I put this log E base V2 by V1 value of this here, so this log 10 base V2 by V1 gets cancelled, and 1 Napier comes out to be 20 log 10 base E. And if I calculate this, this comes out to 1 Napier is equal to 8.686 dB.